So last day we started integration, and I gave you a few questions, right? But I want to see. Let's run over it quick, right? All right. So first thing we need to remember, how to integrate. So if I give you something like this, the integral of 3x squared plus 2x plus 1, right? I'm about to integrate. With integration, we add 1 to the power, divide by the new power. So we add and divide, right? To integrate 2x, you add 1 to the power, divide by the new power. How you integrate 1 again? What's the integral of 1? 1x, right? So that'll be 1x. And what was the last thing that we write? Plus c. Okay? So the integral of this is this, right? And the last thing we did last week, we looked at dealing with definite integral. Math, right? Math? Yeah. Right? And the last thing that we looked at how to deal with definite integrals, which means that we have what? We have values here and here. That's okay? Anybody?
Excuse,
Yeah?
what day was the last advanced class? No, Monday?
No, last Saturday. You missed that class, right, mistake?
Oh, yeah. Sorry. No, cause last class we did intercepts and stuff. That was the last thing.
That was before class, right? But last Saturday, we had a next class.
When is the Form 5 class?
That's this class now. On a Saturday, 8:30.
All right, okay.
Right? So you missed this last week.
Okay.
Right? Right. So if you look here, right? After we integrate, the 2 will cancel. You'll get x cubed plus x squared plus x. If I gave you limits, what you have to do? What you have to do? Plug in the first value and then plug in the second value and subtract them. So let's say I wanted to do that here. After integrate, remember integration, add 1 to the power, divide by the new power. And then when you reach here, now you plug in your 4. Work it out. And then plug in 2. Work it out, and that's your final answer. Always subtracting, and you're always putting the higher value first, then the smaller value after. Okay? The higher value always on top, the lower value always underneath. That's okay? That's integration. That's what we did last day. Everybody okay with that? Yeah? So today we're going on to different types and slightly harder ones, right?
By chance, do you have the recording from the last class or no?
Same place on YouTube, right? Name of this
Okay.
on the line.
Okay, thank you.
So use a mic when I go online. Turn on mic and use it. Right? Just one more easy example, just to make sure we remember how to solve it, right? Let us try. Let me give you a little fraction. Actually, I'm not giving you a fraction. 5x to the 4th plus 2 minus 2x. Right? And the limits are 2 and 1. So a quick review. Try that fast. What you got, right? The whole thing. Right? So when you integrate, remember, once you start integrating, remove the integral sign, right back 2 and 1, and then move this out, right? 5x, add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. Don't write plus c because they what? Remember? Just cancel off, right? They cancel off. Right? So you don't write the plus c because they'll cancel off, right? I just wrote it here because I was doing a different example. Right? 5 will cancel, 2's will cancel, so you'll get x to the 5 minus x squared, and we have to plug in 2 and 1. So when you plug in 2, it'll be 2 to the 5 minus 2 squared, minus 1 to the 5 minus 1 squared. Right? This is 0, 1 minus 1, that's 0. Right? 1 to any power is 1, right? So you don't matter work this out. 1 minus 1 is 0. This is 2 to the 5, what's that? 32. 32 minus 4. Right? 20. That's okay? You got it, all. You get 25? Oh, 28, yeah? Right, nice. So a change in type now. A change in the type to look like this. Right, so there's like a second rule, so you can head up rule number 2. Sometimes you're going to see them looking like this. Right? Sometimes you're going to see them. So this is like rule number 2. Sometimes we have to integrate functions like this. Ax plus b to the power of n. Right? If they look like that, if we go to that, a similar rule. But the bad thing is you have to remember how to differentiate. Right? Because although it's integration, you have some differentiation in it. So watch it here. The rule is this. The integral of ax plus b to the power of n is, right? What's up with you? Downstairs. Yeah, fire down. Right? Here's the rule, right? The rule is this is ax plus b, right? You write back that. You add 1 to the power. You divide by that new power, right? But here's the new part. Whenever you're dealing with functions like this, you have to differentiate inside the bracket. So to get this here, you have to differentiate inside bracket. The differential of ax plus b is 8. All right? Right? So the differential of ax plus b is 8. Right? So for those who don't remember how to differentiate, you're going to have to just go over that. Just basic differentiation. It'll really be hard on that. Okay? For those who never did differentiation, let's take a glance here. The differential of 3x. In integration, we add in and we divide it. Right? In differentiation, it's do the opposite. You minus and you multiply. So minus and multiply. So if I ask you to differentiate something like this, you multiply the 2, you write back the 3x, and you minus 1 to the power. So you'll get 6x. Okay? Watch again. Watch again. If you have 5x cubed, you bring down the power, multiply the power by 5, and you minus 1 from the 3. So that's 15x squared. So you're just doing the opposite. Okay? What's the differential of 7x? 7x to the power of 1, you bring down the 1, write back the 7, minus 1 to the power. 1 minus 1 is 0. Anything to the power of 0 is 1. So the differential of 7x is 7. Okay, that's how I got the differential of ax plus b is a. All okay with that? Right? For now, I'll give you a few easy ones. All you have to remember, if I give you 3x plus 1, the differential of 3x is 3. Differential of 1, 0. So the answer is yes, 3. Okay, so I'll give you them looking a little bit like that, right? But for those who did not do differentiation, let's make a quick note of these here fast. Right? If we didn't do differentiation, make a quick note of those. Right, so my guys, take a look at the first differentiation video, right? Online, you're okay there? So the rule in integrating things like this, add 1 to the power, divide by the new power, and divide by the differential, right? And for now, add plus. Copy down these small examples here on how to differentiate, right? All these are how to differentiate. All right, let's go. Let's try a small example in this, right? Integral of 4x minus 1 whole cube. Right? Help me out here. Help me out here. Kai. Kai, you know, I'll pick you, Kai. What's the first thing to write? Following the same steps from here, right? Step 1, step 2, step 3, step 4. 4x minus 1. 3 plus 1 over 3 plus 1 by 4. The differential of 4x minus 1 is 4. That's okay? Something missing. Plus. That's okay? And you can write it like this. You can write it 4x minus 1 all to the power 4 over 16 plus c. But if you want, you could write 1 on 16. Okay? Copy it down. Copy it down. Online, all okay? Anusha? Yeah, were you okay online? Lisa, you online today? Come on. Let's combine it, right? I'm gonna give you a limit now. Right? So you're doing the same thing, plug in the value and work it out. Right? So try number 2. I'll give you a limit. What to give you? I'll give you 3, and I will give you 2 because some of you expanding these things bad, right? And let's put 2x. Let's put minus 1 here and a 4 here. Because that's enough. Find the integral, and then plug in your value. When you get online, message your answer, right? Message your final value. Take your time, integrate it, and then plug in the value, right? Go to the calculator, remember you can check in the app. Right, okay. Yeah, wait a minute. Take your time, move it out. Integrate that and plug in the value. Right, that's cool. Right. That's right, that's right. Good, good, good. Right. I have that. You can leave the another fraction, right? Just think that. I think we have to wait. But it's done. Yeah. Same thing I did, same thing I did here. Integrate those and then wait. Integrate mean the following was that's it. And big numbers, right? Big numbers. Okay, I don't know. All right, let's go. Let's see online. Jason looking good. Jason good. Sebastian good. Elizabeth, remember you working out the value, right? Who's that? Crystalline good. Any more? Check back yours. Somebody has 16 on back. Ahmed, check back yours. Right? So how we doing this? Right, remember, once you start to integrate, take off this symbol and put back the 3 and 2, right? Right? What's the integral? Right? And if you do understand, write down the steps. Step number 1, put the bracket. Step number 2, add 1 to the power. Step number 3, divide by the power. Step number 4, differentiate inside the bracket and divide by it. Okay? So it will be 2x minus 1, add 1 to the power, that's 5, divide by the power, and divide by the differential of 2x minus 1, which is Okay, that's all you have to do. Right? 3 or 4 basic steps, right? So this says 2x minus 135 all over 10. Right? When you reach here now, all we have to do is plug in the three, do right? Watch it if you confused. Those spend time writing it down. It doesn't go in anyway. Right? Make sure you understand what's going on, right? So step 1, 2, 3, 4. When I finish, now I'm going to unplug in 3, work out the whole thing, plug in 2, work out the whole thing. Right? So that'll be 2x, that'll be 2 by 3 minus 1 all to the power of 5 on 10. That's the first value, minus 2 by 2 minus 1 to the power of 5 all over 10. Right? So this is what? 6 minus 1. So that's 5 to the 5 over 10. This is 3 to the 5 over 10. Right? And most people got 1441 over 5. That's okay? Anybody confused? Everybody okay with the steps? Right? All you have to remember, all of mine might be challenging for some people who don't do differentiation and to show to differentiate, right? But I'm trying to give you simple terms to differentiate for now. Right? But I want you to go over that the first video on how to differentiate. Okay? So that's the way you work it out, right? Copy it down. Let's do our next one. Okay, yeah. Right, just take your time with your signs here, right? The integral between 1 and minus 1 of 3x plus 2. Just to make sure you don't get bad values, just put square. And then I'm going to give you a square root. Take your time. Take your time, usual. Anybody confused online? Right, come to this method your answer, right? And we just saw your mistake in the last one. Yeah. Ayan, capital. Ayan. All right, let's check it out. Well, yeah, right there. All right, let's see what we got online. Okay, good job, Jason. Up here, we all got it right there. So you have 1 minus 1. This is 3x plus 2, all to the power of 3. Add 1 to the power, divide by the new power, and divide by the differential here. And then, right, remember I told you, if you want, you can pull out a value. So this here is 1 over 9 multiplied by this. So if you want, you can pull out 1 on 9. And then have the 3x plus 2 cube here, right? So remember, whenever you multiply the function by any value, you could pull that value outside, right? But remember, let's just say it was 9 by x. You can't pull out x too. You can only pull out a constant. Okay? So what will happen now is that we do have more fractions to work with. Okay? So now I can just plug in my 1 and my minus 1. So I'm plugging in 1 here. 3 by 1 plus 2 cube. And then I'm going to plug in the minus 1. 3 by minus 1 plus 2 cube. So that's 1 over 9 by 3 by 1 is 3 plus 2 is 5. So that's 5 cube minus 3 minus 3 plus 2 is minus 1 minus 1 cube is minus 1. That's okay. So I ended up with 125 plus 1, 126 over 9, which most people got at 14. Yeah. Right, that was just to wake you up. Now let's do some hard maths. Yeah. Time for hard maths now. No. That was just the intro. I just to make sure you wake up on it. Any questions online? Let me see. Some people online are sending me anything. Let me start to message people here. Elizabeth is still a little mistake. Okay. I'll just get all the. Everybody okay with that? Right? Then just want to add a little square root. Right? And because we good, I'll give only a 1 and a 0 here, right? Try that. I'll give you something easy. Go ahead, have fun. Do that one there. What does square root mean again? To the power of a half. Right? Go ahead. Whole thing in power. Not bad here. Right? Remember, square root means to the power of a half, right? Take your time, right? Alexis, go get us an answer. Garcia again, sure. Fini, don't start already yet. Ain't said anything until Fini. Ready? Attack. Just remember what is square root represents, right? Are you ready? And you calculate that. I mean, right, I just write in one line just to make sure they have this. This is 4x minus 2 all to the power of a half. Right? And then you follow these steps and work it out. You put the target and get the X started. You get an error. Yeah, I don't know why. I don't know. Which one? All right, let's see. So what we got here? 1, 0. You write back the 4x minus 2 to the power of a half. You divide by that new, sorry. Add 1 to a half and you'll get 3 and 2. So you write 3 and 2 here and you multiply by the differential of 4x minus 2, which is 4. Okay? 2 into 4, that's 2, so you will get 6 here. So I'm pulling out 1, 6. And I have 1, 0 here. But okay with that? Underneath here is 6, so I just factor out the 6. Okay, well, 1, 6, because it's 1 over 6. Right? And I'm going to plug in 1 and I'm going to plug in 0. So that'll be 1, 6 by plugging in 1. That'll be 4 by 1 minus 2, all to the 3 and 2, minus 4 by 0 minus 2, all to the 3 and 2. Right? So this is 1, 6 by 2 to the 3 and 2, minus 2 to the 3 and 2. This should be an error because we can't find the square root of a negative number. So that's probably why it happened like that. Yeah. So this here is an error. Right? So ignore that, right? I just make it up, sorry. Right? But this is a square root. That's okay? This half means square root of an minus 2 to the 3 and 2 is like saying minus 2 cubed square root. Right? But when you cube minus 2, you get minus 8. Right? And if you square root minus 8, error. That's okay? But once you reach till here, okay. Everybody okay with that? I just make it up when I give you bad values. Second. So you can leave out here. Up till here is good. No, I just make up. Huh? No, you wouldn't get a value. If you put this link, I get, then you'll get error. Right? Right. So here's the problem with integration, right? The problem with integration is that it's not going to be this straightforward, right? You're not going to they'll mix it up. And you're going to have to figure out which rules, right? But before I mix them up, I wanted to show you one more integral of tricks. Right? Head up integral of tricks. This one easy. This one easy. The only problem is that we have to change our calculator to radian. Right? Because these questions are in radian. Right? Head up integral of tricks. Radian. Yeah, from degrees to radians. Remember DRG and convert it. Right, so I'll give you the rules first. The integral of cos x. I'll give you the integral of sin x. Then I'll tell you how to integrate. Right, so this is the first rule, second rule, third rule. Integral of cos ax plus b. And last one, integral of sine ax plus b. Yeah, put questions in cos sine and sine because you don't get tan. I had to be in radian. Pretty easy. But you have to know I change it back. Right? Last set of rules that we had to learn. No more, right? It's the last 4 rules that we have to learn. Whenever we integrate cos, the answer is sine. That's it. The integral of cos is sine. Right? The integral of sine minus cos. That's okay? Watch this one here though. All right. Watch this 2 here. These 2 are a little bit different. Right? Slightly different. Right? Here's what you do. The first thing you do when you're integrating something like this is that you write 1 over the differential of the bracket. What's the differential of ax plus b? So it's 1 over a. Right? So it's 1 over the differential of the bracket, which is a. And then you continue here. The integral of cos, the sine, and then you write back ax plus b. Right? I'll show you a small example lesson, all right? Here, last one. Same thing again. 1 over the differential of ax plus b, which is a, right? And then the integral of sine. The integral of sine, I put in the minus here, cos, and then I write it back, ax plus b, I'm leaving it in a bracket. Are you okay with that? Right? For your rights, just watch a small example. One easy example. Integral of cos 3x. What's the rule again? 1 over the differential of this. What's the differential 3x? What's the integral cos? Sine, right? And then we'll write back 3x. plus C. Right? Watch again. 1 over the differential of 3x, right? By the integral of cos, which is sine, then you write back 3x. Okay? For those who don't remember those things, write down the steps, right? Step 1, 1 over the differential of 3x. Step 2, integral of cos. Step 3, write back 3x. Okay? Write down 3 steps. All right? Copy it down. Copy it down, and I'll bring somebody on the board to do this one here. Right? If you need a in it, copy it. Copy them down and then try sign to it. Right? Actually, I have all the root highlighted. So when I give you the limits, your limits will have to be just linear left on the first part, right? Check it out. Just delete. Right. So when I give you limits, Shahara. Sharan. Sharan. Again. I don't know. Can Sanjay. Right. Try next. Sharon. Elijah. Or no. Brianna. Alright, so what you get here? Right, then I'm gonna leave you on your own to handle something with the limbs. Right, quick question here. Right, first thing we do, 1 over the differential of 2x, which is 2 integral of sine minus cos. Right, and then we put back the 2x plus. That's okay? Right, now I'm gonna give you 1, but in this one here, oh, by the way, if I had a 4 here, what to do? If I had a 4 here, what to do? Nathan, what you would do? Yeah. Take it out. Put the 4 out here. And then when you do the whole thing, you can multiply by 4. That's okay? If you had a 4 there. Remember, it's a constant and you can take it out, right? Anyway, number 3, do this from cos 2x. But here's the problem, right? The problem is the limits I'm giving you is in radians. So your calculator has to go from D to R. Okay? Sometimes these don't work out, but let's hope for the best. Pi on 2, pi on 4. Pi. Why? Because it's in radian. Then right? All you watch. If you didn't, you all did some of you all did tricks on there. Alright, even if it didn't do tricks, right? Right, but this is what you do it, right? Whenever you see this, all you're doing, you put your calculator in radians in R and then plug in the answer like normal. Only when you see this, it's going in. Well, when you see this, you will see this. So to the related. When you see cos and sine, you will see. But then you do this. Right, upside Batiste, but this will be online. Batiste, for example, if you are nice, put in to right, Narayan instead one answer for the day. Narayan, what's going on? And you up here, you right up there. Right, so I want to work out that there for me, but I also want to plug in the limits, right? But yeah, sharp, let's put the out. Casio go to mode, step up, and then switch the answer units. I got it. That text right. Right, that's what we get. Guys are different unit that is awareness. Yeah, you all do that. Huh? What's that? So type of put the mode is right by your right finger, by your right thumb. And what's called again true? Right, yes. Send your values. And with the yeah. Ask you people, you go to shift, setup. Yeah, menu setup right there. And then you go to angle unit and press 2. Then radian. Come now, that's fine. Yeah. Right. And then play it back into normal. Right? So put it back like normal. Right? Same way you play it easy, just playing it high on one time. All right, let's see what you got, right? That's not. Let's see what you got. So when you integrate, right, the integral should be easy, right? The integral of sorry, it's 1 over the differential of 2x, which is 2. Right? The integral of, sorry, the differential of 2x is 2, so it's 1 on 2. Integral cos is sine, then I write back 2x. That should be easy, right? So here's where the new part comes, not harder, new. I pull out the half, right? And I'm going to put in pi on 2 here. So that'll be sine 2 by pi on 2 minus sine 2 by pi on 4. Right? So pull out the half outside, I plug in pi on 2, and I plug in pi on 4. Now your calculator has to be in radians to work it out, right? But because you all did tricks, you all should know these values from the top of your head. Yeah? Good one. All right, that one. Right, let's see. What is sine pi? Sine pi is how much? Sine 180 is how much? 0. Right? Put it in the calculator and see. Right? Sine pi is 0. Make sure I calculate in radians, right? Sine pi on 2 is 1. So the answer is minus 1/2. Huh? Minus a half. Right? Minus a half. Want to get up? Yeah. Yes. Right. Casio people, how to put it in radians. Press shift, setup. Right where the menu button is. Right? And then you will see options come up. You will see angle units. Press 2. Right? And then when you press angle unit, you will see degree, radians, and radian. You press in 2 for radian. Now it's in degree. Now it's in radian. Break it down like me. Break it down like me. Go by 2, go by 2, right. Then wait, let's do that. 75 most of it. 2 times. What am I going to reach there? In shop, if it was wrong. That's why. Right. What's the reason? Oh, what is that shop? Yeah. Right, that's what I mean. Yeah. Let's go again. I'll give you a past paper, that's right. Same thing on a past paper, then check the. You see, what is behind is that you gotta remember all this come exam time. I'll show you how easy it is in a past paper. Huh? You see, what you see. Try this next one here. Any questions online? Oh, sometimes, right? Instead of an X, you might see theta. Nothing changed, right? See, that's change the variable. All right. So that's changing it here for you. In case you see a question, instead of an X, you see theta. You're doing the same thing like normal, right? That's okay. Do it just like normal. Try this one. Let's see if we get it. Yes, exactly. Make a little note and remind yourself to work in radians, right? Right? Book it out, study value. Elizabeth, remember when you see limits, those are little values on the integral sign, you'll end up with a numerical value as the answer, right? So you're not sending the function, you're just sending the numerical value. We get something we're to worry and you might not make this one up. Next one. It will look good. Anybody confused? Right, good. Sure, confused. Right, so take it to outside, see again, I didn't do it in training. Yeah, pretty sure. So you can put this whole thing on, or it's tree by microphone. Right. This way, when you all get added to the group, you'll put it on mute one time, right? I'm going to put that Google form, and you have to fill out the Google form to put the email address. And that what we're going to use to add it to the element. Okay? Make sure, it's something that you have all the videos and notes on it. Right? Okay, and when we add it to that, you're going to have homework and things that finish. small squares is nothing to do. No. Okay. Yeah. All right. All right, let's see what you got. Right, you can pull the 3 on the outside. You have your pi and your 0 here. 1 over the differential of 3 theta is 3. The integral of sine minus cos. And then you write back 3 theta. The most common mistake is that we forget the integral of sine is minus cos. Okay? Minus 1/3 by 3, that's minus 1. So I'll even that there. I don't want to work with that at all. And then I am going to plug in pi here. And I am going to plug in 0 here. So it's minus 1 by cos 3 pi was how much? Was cos 3 pi minus 1? Just work it out for me now, please. Minus 1. And cos 0 is 1. So the answer was 2. You got that, Jeremy? Huh? So I don't want to work with it. Any constant that put it out there, easier to work with. But you don't have to, you can leave it there. But you have to multiply 3 by minus 1/3, which is minus 1, right? So you'll get the same thing. Huh? Then you can't pull it out. You'll find a way to simplify it. Or you wouldn't get like that this level. That's such a big cut off. We now here. Like that. I got negative 1/3. 1 over the differential of 3 theta. No, I use because I have 3 theta here. One is like this, like excellent. But I know it's up to focus on the bottom. If it makes sense, yeah. All right, past paper. Yeah. All right, down all right, down instead of just showing it, right? Right, this past paper was 2013. I can't make all the values there, but I will hope for the best. Right, this is 2013. They want the integral between pi on 2 and 0. Watch what they did, right? They gave it 3 sine x minus 5 cos x. How are you doing that? How are you doing that? Do this one first, and then do this one. That's okay? No? All right. Oh, you just don't want to do it? Okay. All right, I'm gonna change it, and then I'll give it out. You done right, you done well. No, you still gotta do it. We have time for 2. All right, there's a past paper as well. There's 2015. Anyone you want to do first? Right? This one here, you just work out this, then work out this. This one, well, you've been doing it all the time, right? Go ahead, have fun. If you're not having fun, don't do this, huh? If you're not having fun, go do it. All right, so do this one first if you want, and then do this one, right? All this means that you have 2 functions. You just doing it separate. Okay, integrate this, and integrate this, and then do your thing there. Go ahead, hurry up. We have 2 to do. We only have 9 minutes. If I get paid for homework, you know it coming back here and not done, right? So hurry up, do all those 2 fast. I see that's another answer, right? And Narayan. I know you're there, Narayan, but you ain't send any answers. Right, I am more interested in the way we handle number 2, right? Right? All I'm gonna do is gonna write it differently, so you shouldn't be complaining as much, right? Right? This is the same thing as that. You integrate this, and integrate. I just separate this here, right? I just separate the integral, right? Jeremy, do this here from a class. What's the integral of this? 1/3 3 theta. What am I laughing at? Did you get it right? What's the next step? Pull out the 1/3, right? And what do you write here? What is doing in each here? Josh? Bio here. Come fast, Jeremy. Bell gone ring, hurry up. Sign what? 3 by pi on 3 minus sine 3 by pi on 4. And I see everybody going to the calculator and you already check, you should know these values, huh? Right, next week, you're gonna code on tricks. Right, sine pi, that'll be 0, and here will be sine pi, that's -1. Anybody got -1/3? Yeah. -1/3? Nice. Are you okay with this? Right, so you all reach past paper level, right? The trick is if you could remember this tomorrow, right? Not even next week, but I'll forget it by next week. Oh yeah, to the south fast. We have 4.5 minutes. Oh yeah. Anybody confused with number 1? Everybody okay, right? Take the time, do number 2. Number 2 is just 2 functions, right? But I separated for if you want. Right, last part. Right, last one, the integral of sine is minus cos. And then you plug in your values, pi onto 0. On this side, integral of cos is sine. Right? So I write it like this, it might look a little nicer, right? Okay. Then you plug in pi on 2, and then you plug in 0. Right? Huh? The integral of sine minus cos. Right? And then you do the same thing here. You plug in sine pi on 2 minus sine 0. When you work out this will be 0 minus 1. When you work out this will be 1 minus 0. So this is 3 minus 5, which is minus. Yeah. Yeah. I was just showing them. Some people were kind of worried when they saw two terms. I was just trying to show you that it's two separate things. But yes, you can do it one time. All right. Right. So next week, test on this and tricks. Right. And we have to move on to the applications and integration now. But you will not be able to do the applications if you forget how to integrate. All right. So please remember how to integrate.